Okay guys, welcome back to another video. Today we're gonna be taking a look into this really interesting admath question from the October-November 2022 paper 1. Okay. So over here the question states that particle P moves in a straight line such that t seconds after passing through a fixed point O, its displacement is given by this. Okay. Show that the velocity of P at time t can be written in the form this, where A and B are integers. So इधर आप देखो कि इधर they've given you the formula for displacement. So let's just write this down again. S is equal to 2t plus 1 3 over 2 t plus 1 minus 1. ठीक है. So I want you to pay a little attention to this part. तो जो वेलोसिटी होती है, velocity is the rate of change of displacement. So velocity measures the rate of change of the displacement of an object. ठीक है. So because इसमें हम rate of change की बात कर रहे हैं, so that means the derivative या d dx of the equation of displacement is going to be equal to your velocity, right? So basically what all we have to do is we have to differentiate this. Okay, and we're going to do that in just a second. Okay, so here we have the equation which we have to differentiate, and I want to write a few things before we get started officially. So the top function, the numerator of the quotient is gonna be u, and the denominator is gonna be v. And because this is a fraction, so we're gonna have to use the quotient rule to differentiate this. And the quotient rule states is as follows: v u prime minus u v prime over v square. ठीक है. So we write v as it is into the derivative of the u function, मतलब the denominator, minus u, the numerator, into the derivative of the second function, which is the denominator over the denominator whole square. And that's what we're gonna do. So पहले हम v as it is लिखेंगे. So t plus 1 remains as it is into the derivative of the numerator. So numerator may we first use the power rule to get 3 over 2 down. So this becomes 3 over 2 into the inner function, which is 2t plus 1, and power may say we're minus 1. So this becomes 3 over 2 minus 1 into the derivative of the inner function of 2t plus 1, and the derivative of that is just 2. ठीक है. Minus the numerator, the first function, which is 2t plus 1 into 3 over 2 into the derivative of the second function, t plus 1 derivative, which is just 1, all over the denominator square, so t plus 1 whole square. And minus 1 is just a constant, so its derivative is 0. So let's start simplifying some stuff here. We get rid of this and this cancels, so we have t plus 1 into 2t plus 1, and 3 over 2 minus 1 is 1 over 2. ठीक है. Minus 2t plus 1, 2t plus 1 to the power 3 over 2, and into 1 can stays as that, over t plus 1 whole square. अच्छा, so हम इस फंक्शन में से 2t plus 1 का स्क्वायर रूट को कॉमन ले सकते हैं, and that's exactly what I'm gonna do. तो we can say 2t plus 1 power की half can be taken as common, and over here we have 3 into t plus 1 minus because we already took half common, so 2t plus 1 is just to the power of 1. Like, and remember there's a minus sign over here as well, so be careful to multiply that out thoroughly. So plus 1 becomes minus 1, and here we close the brackets, and we have all of this divided by t plus 1 whole square, right? So let's go back to the question. The question says to give your answer in the form this. तो आपका जो डिनोमिनेटर है दैट इज़ ओनली डिवाइडेड बाई 2t plus 1 का हाफ, ठीक है, एंड द अदर स्टफ इज़ without the denominator. So we have to make our answer in that form, and we can do that by doing 2t plus 1 power half over t plus 1 whole square into this function right here, ठीक है, and this function is comes out to be simplified to 3t plus 3 minus 2t minus 1, ठीक है, and so our final answer is going to be 2t plus 1 half over t plus 1 square into 3t minus 2t is just t, and plus 3 minus 1 is plus 2, and that is your final answer, and this is obviously equal to your velocity. Okay, so the second part of this question asks us to show that P is never at rest after passing point O. So when you mean at rest का मतलब होता है velocity is equal to 0, and we've already found the equation of velocity in the first part, so we just have to set this equal to 0 and show that there are no possible solutions. Achha, so I've written the question again, and is written the equation for velocity again, and is dafa I'll equate this to be equal to 0, ठीक है, and we have to solve this accordingly. Now t plus 1 मैं उधर जाके multiply कर दूंगा, so 0 times anything is just 0, so we get 2t plus 1 brackets में power half into, actually let's write this like this, t plus 2 which is equal to 0, ठीक है, and now ये एक quadratic equation, एक quadratic expression की factorization की तरह है. First we're gonna solve this while this is being equal to 0. Yeah, we're gonna solve this by letting this be equal to 0, ठीक है. So the two possible solutions that we can get is 2t plus 1 power half is equal to 0, or t plus 2 is equal to 0. So right वाली equation solve करना बहुत आसान है. t is equal to minus 2. अच्छा, so you can say कि answer तो अब आ गया. Why are there no solutions for this? Because time which t represents can never be negative. So that is why no positive solutions exist for this equation, right? तो इस equation से हमारा we have been unsuccessful. Let's do the same thing with the left equation here. So either let's square both sides to get rid of the square root. So we get 2t plus 1 is equal to 0, 2t is equal to minus 1, t is equal to negative 1 over 2. And again we face the same issue, kt is negative, so there are no positive solutions, and we have hence proved that P is never at rest after passing point O. And that's gonna be it for this video today. If you guys like this video, please consider subscribing, liking, all that good stuff, and I'll see you in the next one. Allah Hafiz.